Welcome to today's People Product Knowledge segment featuring the Hiniker Nitro-Lert system for your anhydrous applicator. Let's back up and think agronomically of what is the number one and number two input as far as dollars is concerned that we're putting on our corn acre. We're putting about $100 to $180 an acre of corn seed, and on our planter we're putting thousands and thousands of dollars of systems to monitor and adjust downforce, singulation, spacing, closing that trench and furrow. But what are we doing as far as the $50 to $100, the number two product as far as dollars on our corn acre? What are we doing on our anhydrous applicator when we're putting $50 to $100 worth of anhydrous on that same acre? We all have heard about that broken knife, but hey, you know what? Every time I turn around, I kind of look and make sure there's enough smoke or gas coming out of every anhydrous knife within about a split of a second of looking behind me when I'm turning. That's about all we're doing. But we're not doing anything when it comes to understanding if we have restrictions or plugs, a plugged knife, a distribution manifold that's restricted. That's what the Nitro-Lert system is going to do for us. Let's take a look and understand how it works. In the cab, you're going to have a monitor that complements your Raven or Ag Leader or John Deere monitor, or even your Raven 440 monitor. Those are the things that are controlling the flow. This is going to alert you and help you understand the distribution on your toolbar. We're not controlling nothing. We're monitoring and looking for problems on the toolbar with this. A simple monitor go in the cab, a 12-volt power supply going into your most common corner plug in your cab, with a wire going out the back of the cab down to the implement cable. So at the tongue, you're going to have a disconnect. But from the anhydrous applicator standpoint, the anhydrous is coming from the tank into the Raven flow meter and cooler, and then out to the individual distribution manifolds on your toolbar. How it's going to hook in there, you're going to have a hookup into the master on-off, so it knows when your applicator is turned on. And it's also going to be wired into the system on each on-off valve for however many manifolds you have on the toolbar. And then you're going to have a cable that runs back to the machine, and you're going to have a daisy chain sort of system as to how it's hooked in to all these sensors on your toolbar. So these sensors here, here's a better look at it of a John Blue and Pelicone distributed out in the anhydrous out to every row of the toolbar. In the kit comes the temperature sensor and a 4-inch piece of hose to go on every hose barb. So we're looking at consistency. If you think about the planter, consistency. It's the same thing with the anhydrous applicator. Consistency and perfection. What are these sensors that's measuring the flow out to every row? There's nothing physically happening. There's no impellers turning or spinning. What this is, and if you think about the properties of anhydrous, this is a temperature sensor. So anhydrous, when it's flowing through the toolbar, if you speed up the flow out to the knife, or if you restrict that knife, like a plug knife, and you're slowing up the flow of anhydrous out to that knife, you change the temperature because that's how anhydrous reacts. So if you look at this system, and again, we're measuring temperature, not flow, I'm going to put my hand over one of these sensors, the one on the back here. We're going to slowly watch the bar graph. This monitor is set up for a 6-row toolbar, so you got a bar graph for 6 rows, and you can see my hand is on row number 3 temperature sensor back here, telling you as an operator there's something to start going wrong on row number 3. What would you do if you were planting corn and row number 3 showed a problem like this on your planter? You would stop in the middle of the field and get out and fix it. That's the same thing that we're going to do with the anhydrous applicator. As row number 3 gives us an alarm, we're going to stop in the middle of the field and try and figure out what's wrong. If you understand the bar graphs here, this top line is what that row had to hit before it gave us an alarm in the cab. That row is actually set, alarm point set on 30. That row, number 30, actually indicates that row number 3 had a 3 degrees, alarm point 30. That row had a 3 degrees different variation from the other rows on the toolbar. So we get out, we look, A plugged knife is a very common situation that we've all seen streaks in the field, our neighbor's field, of course. A plugged knife. What else could be going on row number 3? We could have sheared a bolt on the knife and the knife comes up and it restricts and pinches that EVA hose on the back that's feeding that knife. That could be another problem. Another problem we've had customers call in with is, man, I've got one row that bar is up there giving me an alarm all the time. Well, what we figured out with that customer is on his 24 row applicator, on row number 4, he had broken that knife, and the knife that he put back on was made by a different manufacturer. So the physical properties of that knife was different from the other rows on the applicator. There was a little bit more restriction in that knife versus the other ones. So what was taking place is that knife was under applying. He would never have known it because there was gas coming out when he turned on the end rows. But what he found with a monitor like this, he was able to realize that, you know what, I need to get a knife from the same manufacturer because that was the problem in that scenario. So we've been talking about individual rows. Problems on the knife, it's plugged, it's restricted, had a different knife on there. But let's talk about the distribution across the planter. In this scenario, the distribution across your anhydrous applicator. Other instances that have happened is a customer had a 2-section toolbar, meaning he had 2 distribution manifolds. And again, all these sensors are reading all the lines, but the one half of the toolbar, the lines were all reading a lot higher than the other side of the applicator. Through going out and helping him figure it out with Ag Solutions Group service technician, we figured out by opening this distribution manifold, that manifold had a piece of rust in there, restricting the flow of that impeller in there, reducing the amount of flow coming out of that section of the toolbar. There was still gas coming out of the knives when he looked. But when it comes to even distribution, we know that Raven flow meter is measuring it out and the control valve is giving me that 170 units per acre. But how is that 170 acres being distributed through my toolbar? We just figured out with that customer, there was a lot more going out of section 1 of that 170 units and a lot less on the section 2. We may or may not have seen that on a yield monitor. Sometimes you can see that kind of stuff on a yield monitor. Depending upon your head configuration with your toolbar configuration, you can see strips. And in this scenario, an example, half of this toolbar, a 60-foot toolbar, he had 30 feet that was under applying by a big percentage. That's one thing the Nitro-Lert Hiniker system can do for you. Let's keep talking about distribution. On an anhydrous applicator, we all know that all the hoses from every row have to be the same length for good reason of how anhydrous acts from a physical standpoint of the product. So as you have that long hose out there and as you start getting closer to the manifold, you get the coiled up excess hose. We have another instance, and many times you can see the inaccuracies in the flow across the toolbar by how tight people are wrapping and coiling up that excess hose on each row. Because if you think about it, the tighter you coil that hose, the more restriction to make it, versus if that coil was looped a little bit bigger, you get even less restrictive flow with a bigger coil. Also, how that coil is positioned on the row unit. If that coil of excess hose is hanging down and gravity is pulling it down and it's got to circle through all that coiled up hose before it gets out to the row unit, versus if that coil was laying flat and just happened to spin on a horizontal surface, less restriction than if the excess hose is hanging like this. So there's many examples that we've never really thought about. As we started putting these on toolbars over the last couple of years, people were calling in with this problem or that problem or that problem. It's just like the monitor on our planter. It's telling us we have a problem out there. Let's go investigate. So it's been very interesting. It's been a fun product to sell because what we're doing at the end of the day, we're trying to do a better distribution, catch those plugged knives, catch the restrictions, and enhance the efficiency and the quality of application with our anhydrous toolbar. Whether you're a grower, a retailer, or custom applicator, the investment in a Hiniker Nitro-Lert is going to add a lot to your operation.